All right, this is section 5.2 in MathLinks on, it's called Introduction to Polynomials. This is basically defining what like terms are and how to gather them. And in the final section of chapter 5, which is 5.3, we're going to learn how to add and subtract polynomials. So, the first question that we're going to do today is question 5, which is what's the value of the coefficient and the number of variables for each term? So again, it would be very helpful if we go back to grade 7 to define what is the coefficient. Well, coefficient is a fancy word for how many of the variable you have, how many of the attached variable term you have. Or another way to think of that is a multiplier for the variable. Because again, if we thought about, let's say, repeated addition 4 plus 4 plus 4 plus 4, we really realize that that's, we'll do times plus 4. We realize that's 5 multiplied by 4, right? 5 groups of 4. So this is repeated addition, and repeated addition is another way to say multiplication. So we would say 5 groups of 4. In the same way that if I looked at that a term, pretending that that's not negative for a second because it makes more sense if it's not negative. That would be a z squared plus a z squared plus a z squared, or 3 multiplied by z squared, or just 3z squared, right? So if we are thinking about what it looks like as a picture, it's 3z squares, or 3 multiplied by the value of z squared. The only difference, of course, is this is the negative symbol. And again, for me, not for all teachers, but for me, I like to think of that as the opposite value of 3, whatever 3z squares has as a value, then that would be the opposite of that value. Or multiplying the z squared value by negative 3. So going back to this, the coefficient is negative 3. And the number of variables, we have a z squared. So if we were to draw it, we could say that there is, it's one variable, it's a z in that particular term. In the second term, right here, there is no coefficient written. But if I was to ask you how many k's do I have, we would say it's 1k. And going back to the last section, we said that coefficients of 1 and exponents of 1 are never necessarily have to be written. We would think that would be strange. So the coefficient for b is 1, and the number of terms, or number of variables, excuse me, is 1. It's just the k itself. And your last question, 43, what's the coefficient? Now, coefficients, in their definition, how many of the attached variable term you have. Since there are no variables in C, just a constant term of 43, there is 0 coefficients because there is no multiplier to a variable. And how many variables are there? There are no variables. So 43 has no coefficients and no variables. Question 7 gives you a table of 6 terms, and it says which have a coefficient of 1. Now I'm going to use my highlighter here rather than rewrite them. So I'm going to use yellow for coefficient of 1. So for coefficient of 1, we're looking for variables. They have to have a variable term. And in front of those variables, there either has to be the number 1 coefficient written or not written, because of course we understand that you don't have to write a coefficient of 1. So right here, in front of that x squared, is a 1 coefficient that's not written. So therefore, that term has a coefficient of 1. And so does the xt. Xt simply means an x value multiplied by a t value. How many of those xt's shapes do we have? Well, we have 1 of them, so that's a coefficient of 1. Now, some people might have thought this one was, but in front of that ts is a negative sign, which means the coefficient for that ts is actually negative 1 and not a positive 1, which it says in A. In the second question, which have 2 variables, so again, I'll use green for this one. This has 1 variable, just the x. That coefficient of 3 doesn't count as a variable, so it has 1 variable, x. The second one has 1 variable, t. The third one, x squared, has 1 variable, x. Even though it's x squared, we're going to call it 1 variable. Now this one has 2 variables. It has a t and an s. And this one has 2 variables, an x and a t. And the other ones, x squared and t squared, just have 1 variable each, just the x. The third question, C, says which terms only have one variable with an exponent of 1? So remember, the exponent of 1 part, we will never write that typically. So an exponents of 1 are usually assumed to be there even though they're not written. So this has one variable and there is no exponent, so that's an exponent of 1. This one has one variable and is an exponent of 1. And the rest have, this has one variable but an exponent of 2, so it doesn't count, and the rest don't count as well. So just those two terms. And finally, for the last one, which have a coefficient of -1? There is only one value that has a coefficient of -1, and that's that negative TS. That's a -1 coefficient. Question 8 says identify the like terms in each group. So in order for a like term to be a like term, it has to meet the following criteria. So in order for a like term to be a like term, they have to have the same variable or variables, depending if they have more than one variable. And the important part is they have to have the same exponents on each. So if we look for the first question, A, and I'll bring my highlighter, we have in this term here an A. The variable in that term is A. There is no variable in the second one, and there is an A in the third one. So those two terms, 2A and -7.1A, they are considered like terms because they both have A's, and the exponents that are not written are exponents of 1. So they would be considered to be like terms. The rest of the terms in that question A are not like terms, and therefore the only two that are 2A and -7.1A. In the second part, we have an M here as our variable, and the exponent of that M is of course 1. And over here, we have an M as well. And both of those are like terms. The coefficient for this one is 3, and the coefficient of this one is 1 1/3 or 1.3 repeating or 4/3, whatever one you want to interpret that coefficient. All three are the same. So therefore they're the same. And some people might think that M squared is the same, but of course, in order for it to be a like term, it has the same exponent as well, and that doesn't. So those are the only two terms in that. Now somebody asked me, this one's the same except this is a B and this is a D. Again, same reason. They're not like terms because they have to have the exact same variable combination as well. And finally in C, if I look at this term right here, -1.9, that does not have a variable, so therefore it's called a constant. And any other terms that are also constants would be considered like terms. So -1.9 and 5 are like terms. If I look at p squared, there's another p squared. So 6p squared and 1p squared are like terms. And this -2p is partners up with nothing because it's a p with an exponent of 1. Question 10 asks you to collect like terms. So what I like to do, and I think I've told everybody this now at least 5 or 6 times, is I like to take my polynomial and I will box up the polynomial with both the term itself and the operation sign. Because in that second term right here, 2x squared, I must keep the negative sign or the subtraction sign with it because that is going to be thought of as being -2x squared. So there are 4 terms. Now the first thing I'm going to do is I gather like terms or collect like terms is of the 4 terms, which term has the highest degree. And the degree of the term is based by the variable and the exponent. So that one right there has a degree of 2. So I'm going to gather all of the x squares first. So a -2x squared and a -2x squared. I can write down my x squared and just simply combine the coefficients. So -2 and -2 will be a -4x squared. And a 3x will combine with the other like term of x to make plus 4x. Now some people want to just write it as 4x. But if you do that, it becomes just 2 monomials. You need to connect like terms with either plus or minus values. So in this case, a plus 4x because it is a positive 4x. And that's the simplification of that first one. Your second question gives you 5 terms. The term that has the highest degree are your n squared. So a -2n squared and a positive 2n squared are going to make nothing. So we're not going to write down anything. They're gone. The next one is your n's, which is just that one term, -3n. So it's going to remain by itself. And then your 2 constants, a -4 and a positive 3. If you go back to grade 7, 4 negatives and 3 positives make a -1. And therefore the second question will simplify into a binomial, -3n minus 1. Your third question gives you a 6-term polynomial. First ones I'm going to combine are your q squares. I have negative 4q squared here and a positive 3, which is going to leave me with 1 negative q squared. Now notice I didn't write negative 1, I just kept it as negative symbol. That represents negative 1. A negative 3q and a positive 2q gives me a negative 1q, which I'm not going to write again the coefficient of negative 1, just as minus q or a negative q. And a positive 2 and a negative 2 are canceling constants, which means there will be no constant in the simplification, which means I end up with a binomial. D is a 4-term expression. 5c and negative 4c make a c. Positive 3 and negative 7 make a negative 4. So my answer for D is c minus 4. In E, I have 4 terms. A positive h squared and a positive 4h squared is a 5h squared. Don't need the positive symbol. Negative 3h and a positive 2h is a negative h, or negative 1h, which is just negative h. And finally, the last question. There are 7 terms. 1, 2, or 6 terms. 6 terms. 2j squared and negative 3j squared is negative 1j squared, or negative j squared. 2j and 3j is positive 5j, and negative 5 and negative 1 is negative 6. So that's the answer for question 10. So for question 12, it says, which expressions are equivalent to this particular one right here? So what we're going to do is we're going to take all of those expressions and we're going to rewrite them in descending degree of terms, and we're also going to gather like terms if possible. But in the first one, A, there are no like terms. It's a trinomial. But the difference between the simplified expression here and this one is that A is not reordered in descending degree of terms. So I'm going to start with my positive 3x squared, and my second degree term is my x's, and then finally my constant of negative 4. And when I compare the two expressions, I realize that the difference between the simplified expression and the one I just did is this negative symbol. So therefore, A is not the same as the simplified expression that it's asking you to compare. In the second example, if I box them up, sometimes it's easier to see it like this. The first term is going to be a negative 3x squared, then a positive x, then a negative 4. And if I compare them, they are the same. So B is going to be same as the highlighted blue expression. The next one, when I combine my x squareds, I end up with negative 3x squared. When I combine my x tiles, I end up with a positive x. And when I combine my constants, I get a negative 4. So C is also equivalent to the blue highlighted expression, trinomial. In the next one, 2x squared and negative 5x squared makes a negative 3x squared again. A positive x is just by itself, so it's going to remain a positive x. And a positive 1 and a negative 3 make a negative 2, which is not the same constant. So therefore, D is not the same. Let's see if I can do it without boxing it up this time. A negative 4x squared and a positive x squared make a negative 3x squared. A positive 2x and a negative 8x make a positive x. And a negative 2 and a negative 2 make a negative 4, which means E is the same. And finally, there's too many things to do it that way. I'm going to box it up. I like boxing it. X squareds, negative 6x squared, negative, oh, that's the wrong one. Poopy darn. Negative 6x squared and positive 5x squared make a negative x squared. And negative 3 more make a negative 4x squared, which right off the bat I know it's not going to be, and I'm done. Don't have to go any further. I know my x squareds are going to be off, so therefore F is not equivalent. Question 15, for each of the following polynomials, rewrite the expression with 6 terms. So for A, the first thing I'm going to do is figure out, okay, I have 3 terms. I need to figure out how I can use 2 terms that are equivalent to that one term. And there's infinite values. I'm going to start with a negative 5p squared. And you could start with anything. It doesn't matter. In fact, we could have started something simpler. But to that negative 5p squared, if I added a 7p squared, these two terms will simplify to be this term here. And you could have infinite terms. An easier one would have been a p squared plus a p squared, obviously, 2p squared. But I'm going to make it more complicated than it needs to be. The second one, of negative 3p, I'm going to make this one easier. A negative p and a negative 2p, those two terms, 2p, b new, 2p, b new, b new, 2p and b new. Those make that this term right here. Oh, sorry, that's not right. Highlighter, blue, there. These two make this one. And finally, the last one, a positive 2. I'm going to keep it easy. A plus 1 and a plus 1 make a plus 2. So this three-term expression now becomes this sixth one. And you could have infinite variations of that same one. Oh. In the next example, first way to combine that, let's keep it simple this time. Let's go with a negative x squared and a negative 2x squared. That's going to give me negative 3x squared. Keeping it simple for 5x, we're going to go plus 2x plus 3x. That's going to make a plus 5x. And I'm going to go a negative 2 and a negative 2. That's going to make a negative 4. There's a six-term expression that has the same value as the trinomial above it. And finally, keeping this one simple, 2r squared plus 2r squared. These two together are equal to this term. Take away q squared, take away q squared. Those two right there are going to be equal to this term. And finally, minus, let's go with minus 4qr and plus a qr. Oh, keep that one separate over there. Those two are going to equal this one. So therefore, we have a six-term polynomial equivalent to the trinomial above it. Question 16 says, write an expression for the perimeter of each figure. Now, then combine like terms if possible. So this will be a, oh, that's not what I want. This will be a 4D, that's not even 4D. Heavens to Betsy. 4D minus 5, which is this side here, plus a D plus 7, plus a D, plus a D, plus a 3D plus 1. So really we have 1, 2, 3, 4, 5, 6, 7, 8 term polynomial. If we look at it, how many D's do we have in? We have 4 D's, we have 5 D's, we have 6, 7, 8, 9, 10. We have 10 D's as a simplified D term. We have a plus 1, a plus 7, which is 8, and a minus 5, which simplifies to be a plus 3. And therefore, the perimeter of said shape, perimeter equals D, 10D plus 3. In the second one, what's not written, of course, is these two sides here. So if I'm writing the perimeter, I'm going to put W plus W plus W plus 9 plus W plus 9. A W plus a W plus a W plus a W is a 4W. A 9 plus a 9 is a plus 18. So therefore, uh-oh, wrong way. The perimeter of this shape, perimeter equals 4W plus 18. Now, alternatively, I could have done a grade. The next chapter, we're going to learn it's 2 multiplied by W plus 2 multiplied by W plus 9. And we're going to utilize this distributive property of algebra in grade 8 to figure out what it is as. So one of my brilliant students asked me, does it matter when you write A, what do you start with? And the answer is no. I could have started with D plus 7, it didn't matter. But what does matter is you will realize that this technically is the way we're going to get used to writing it. We're going to actually show all of the different sides like this. And I didn't use parentheses or brackets, but technically that's how I should have written the perimeter, and then simplified it by dropping the brackets and gathering like terms. But we'll talk about that in the next section. Question 17 says draw a figure with a perimeter that is represented by this. See the brackets plus this, which is the brackets plus this. So we have three sides that are separated by brackets, so we know it's going to be a triangle. It does not matter what sides you made them. It has no, I don't even care how you drew them. It doesn't have to be to scale or proportional because you don't know the value of s. But that would be what it would be. And if I add them all together, 5s plus 3s plus s is going to be 6s. A negative 2 and a positive 6 is going to be a positive 4. And therefore, the perimeter of this shape is going to be equal to, oh, sorry, I did something wrong there. 8s, 9s, not 6s, 9s. 9s. 9s plus 4, not 6s plus 4. Question 18 says a student council decides to raise money by organizing a dance. The cost of a band is $700. The student council decides to sell tickets for $5 each. Write an expression for the profit that the student council would make. What does your variable represent? I suppose there can be such a thing as negative profit, but we'll just say so. X is going to equal the number of tickets sold. So therefore, the profit will equal the $700 they had to shell out, take away, no, I got that backwards. $5 multiplied by every ticket they sell, take away the $700 it cost them to hire the band, that will be their profit. So if they sold 2 tickets, that would mean they made $10, take away the $700 they spent for the band, their profit would be negative $690 profit, which means they made no profit. They ended up being $690 in the hole. But if they sold, in B, 250 students, what is the profit? Then for B, when I substitute 250 here, they would have raised $750 in ticket sales minus the $700 it cost for the band. Their profit at 250 students would be $50 profit. Ah, thank you. I was thinking 3. Thank God this is only recorded onto YouTube and no one else can see it. It's 1,250, which means their profit is $550, not $50. And finally, it says estimate, then calculate the minimum number of tickets students will need to buy for a students' council to make a profit. So a $0 or a $1 profit, we'll call it, right? So in order for a $1 profit to be given, okay, or to break, we'll say $1 as being the minimum. Or let's say, should we say $1? Well, let's just say $0. In order for $0 or to break even, if I write this equation, and instead of writing profit, I write $0, then if I was to use my algebra sense to isolate and add $700 to both sides, I get 5x equals $700. Divide both sides by 5, and x will equal 700 divided by 5, 140 tickets. So therefore, since we defined x as being the number of tickets, in order to break even, they would have to sell 140 tickets. But to make a profit, they'd have to sell one more ticket than that. And therefore, they'd need to sell 141 tickets to make a profit.